Okay, we learned the ellipse, and right now we're going to learn the second conic section. Is called hyperbola. Okay, now, quick review. Remember when you have these 2 points, we call them foci, and if the distance from the point to both foci stays the constant, or the sum of this distance stays the same, then you get an ellipse, right? What about the difference between these two distances stays the same? We got a hyperbola. All right. So this is very interesting. And the way we can do that is, first of all, the foci, well, the foci, for example, you get this foci, all right? For this point, here is the distance 1, and here's the distance 2. So you can tell this distance is a little longer, and this one is shorter. And the difference is it's about this much. All right, now, I'll tell you what, if you graph, you find all the point, it will look like this. The graph look like this. Because we talk about the distance, and it doesn't really mean it's positive or negative, right? Distance always take the positive. We talk about the absolute value of the distance. Therefore, we have another one on the other side. See, for this point, the distance between this point to focus 1 and the distance to the focus 2, the difference stays the same. Therefore, this is D1, this is D2, this is D1 prime, and this is D2 prime. So D1 minus D2 is D1 prime minus D2 prime. The difference between two distances is a constant. Then you get this hyperbola. All right, now for this hyperbola, we get again, we have some name, okay? So that's called a focus. Focus. Two of them called foci. And this is the vertex. And that's the vertex. All right. So there's something more. I'm going to explain that. And then here is, of course, this is the center, right? And from vertex to vertex, there's a special name for this part. And this center is here. And that, I connected this to, it's called transverse axis. Transverse axis. Okay, so that's from a vertex to vertex. Okay, and later when you graph, there are two lines, and this graph is going to be very close to it. So this is called asymptotes. Asymptote. Asymptote 1, asymptote 2. So there are two asymptotes. All right, now there's just something else. All right, now let me get a focus. Focus. And this is the vertex. Yeah, vertex. Okay. Here's the center. Again, okay, now I ask you to watch me. So from a center to one vertex, this distance, I call that C. I call that A. All right. And then from this center to the focus, I call this C. Did you see something interesting this time? My C is greater. Okay, C is greater. And then there's another thing, of course, it's called a B, right? B. And because in this case, C is the longest one, so C equals A squared plus B squared. I'm going to explain this later, but remember this is a big difference between this hyperbola and ellipse. For ellipse, A is the longest one, therefore you have A squared equals B squared plus C squared. But in this hyperbola, my C is the longest one. Remember, see these two focuses stay inside these two curves. So the C is fairly big, right? C is much longer than A. All right, now here, if you have left and right hyperbola, the equation looks like this: x minus h squared over a squared minus minus y minus k squared over b squared equals 1. This is the left and the right hyperbola would look like. Okay, and if you have something look like this, up and down, and here's the foci, here's the focus, here's the focus, then you're going to have this. You're going to have y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay, I want you to pay attention to this. I still have x squared and the y squared. However, the coefficient of this x squared and y squared, they have an opposite sign. Did you see that? Here's a negative, here's a negative. Here, y squared positive, but x squared negative. I have up and down. If I have x squared positive, y squared negative, I have a left and right. I tell you the shape of it. But for both of that, I always go with x minus h and y minus k. So center is just hk. Okay, it tells you like what's the basic shape of it, left or right or up and down. Make sure your right side is 1. You see the difference between this with the equation of ellipse. It's very easy to identify them because this one they have opposite side. Okay, the other one is plus. If here's a plus, we get ellipse. If it's negative, if it's the opposite sign, then we get ellipse. We get hyperbola. All right. Now one more thing about this hyperbola is this. Let me give you this: x minus h squared over a squared minus y minus k squared over b squared equals 1. All right, now I have the center is hk. That's the center, and I go from the center to the right by a. I get my vertex and the vertex. If I go by C, this is A, and that is C. I get my focus, right? So very similar to the other side. I also have this. This is A, this is C. Now, I go up and down by B. Now, in this case, I never say A must be greater than B. No, AB doesn't matter which absolute value is greater. Okay, A is always stay with the positive one, and B square always go with the negative one. And if you go up and down by B and B, you get a beautiful box. Beautiful box looks like this. Okay, here's A, here's a B, here's A, here's B. Now, and then once I get this box, I can draw this. I can connect this diagonal, create this line, and that is my asymptotes. Asymptotes. Okay, so because 2 of them. And what's the equation of that? Remember, if you have a line that passes through a point with a slope, what is the slope? Rise over run. Rise is B, run is A. So therefore, y minus k equals slope. Slope could be positive or negative, so plus or minus, because there are 2 of them, b over a x minus h. Again, I hope that you don't just memorize that, and you just need to know. Once you know what is A, what is B, what is C, then you can just go ahead and find it. And the graph will look like this, because here is the vertex, and they go from vertex, you draw up and down, and from this vertex, you go curve up and curve down. Okay, so then you get your hyperbola. All right, I'm gonna let you take a look about this. So if I give you an equation, the number, the coefficient under this or in the denominator for this x squared term, this part is positive, so I get the left and the right. And then I find A, find B, find the center. Then you can graph it for sure. All right, now what about the other one? The other one is up and down. Then you have, so you have y minus k squared over a squared minus x minus h squared over b squared equals 1. You see the difference between these two? This is x squared positive, y squared negative. This one, y squared is positive, x squared is negative. All right, now how should we graph that? First of all, we find where my hk is. Here's my center, hk, right? And because this is going to be in the up and down type, so I need to go up and down to find the foci and the vertices. So I go up by A, go down by A, that is my vertex. And then if I go left and right by B, all right, and then I'm going to connect this I'm going to create this box, and I'm going to get this diagonal line. And then because I have up and down, so I'm going to graph starting from here. It's going to be a pretty flat curve. Okay, phew. It's not very good, but you get the idea. All right, now what about the what is the asymptotes? The equation of the asymptotes. Asymptotes. That's going to be y minus k. Okay, that equals. So what is the slope? Slope is rise over run. So the rise is a, run is b. Therefore, it's a plus minus a over b, x minus h. You can see this is b over a, this is a over b, and it's really hard to just memorize that. Even you have like a cheat sheet of all the formula stuff with you, but I hope that you can remember what is this. Okay, from any graph, from this equation, you can identify a lot of things, and you can graph it, and then you can get all the equations you want. All right, now let me give you this one example here. Let me just ask you to this. I ask you to graph the x squared over 25 minus y squared over 16 equals 1, and then find vertices and foci. Can we do that? Yeah. We know the center in this case. That's the easiest one. We love it. The center is a 0, 0. And because this x squared term has this is positive. When x squared has the coefficient of positive, we get left and right. I just ask you to take a little note there, okay? And then under this positive term, under that is a squared. So a squared is 25, therefore a is 5. Of course, b squared is a 16, so b is 4. And c squared is the longest one. C squared is a squared plus b squared, which is 25 plus 16, which is 41. So my c should be square root of 41. It's not a very pretty number, but that's what we have. Okay, so let's graph. We have the center, 0, 0. We should have a left and right type. And starting from here, if I go to the right and the left by A, I get the vertices. So here is a 5, and here is negative 5. All right, so that's my A. And then if I go up and down by B, so I go by 4, and here is negative 4. All right, so I get an A, I get a B, and I get this box. And of course, I can just connect this to diagonal. I get this two diagonal line. And where's my vertices? Vertices is here and here. So you just need to write, you just need to go through, like, let me just use this to count. So you're going to do this, and so you have a really good graph. That's good, right? Okay, now we have done this. So my vertices is 5, 0, and a -5, 0. So what about my foci? My foci is going to start from the center to the left and the right by C. So foci is √41, 0, and a -√41, 0. That's it. So what is the square root of 41? It's about a 6 point something, right? It's between 6 squared 36 and a 7 squared 49. So it's going to be 5, 6 somewhere here. It's √41. All right. Yep, that's good. I'm going to ask you to do one more. Ask you to do this. To graph y squared over 25 minus x squared over 16 equals what? This is very, very similar. We get the center is 0, 0. And since the y squared term is positive, therefore we have the up and down. Okay, so if you have up and down, then this is a squared, this is b squared. So again, my a squared is 25, so a is a 5, and a b squared is a 16, so b is a 4, and a c squared is a squared plus b squared, which is 41, right? So c is √41. So if I ask you to graph, you're going to get something look like that. This is x, this is y, here's the center, and you could go up and down by a, so you go up and down by 5, and here's a -5, here's a 0, and then go left and right by b, so it's just slightly smaller, so it's -4, and then you can get this box. Look at the diagonal line. That's your asymptotes. And then you're going to go from here. And of course, like that. And your foci is going to be 0 √41 and 0 -√41. That's your foci. Okay, so you compare this with the one we just have. Left and right, up and down. And then can you find the equation of this asymptote? Of course, that center here. So this one is y equals rise over run, so it's 5 over 4x. And this one is y equals -5 over 4x. So we also get the equation of this asymptotes. So that's pretty easy, isn't it? This is the hyperbola, and you learn how to graph, and you know how to get the equation of the asymptotes, and also you can find the foci. So let me ask you to do number 3. Graph this. 4x squared minus 24x minus 9y squared minus 90y minus 153 equals 0. And of course, it's pretty hard, right? So what you need to do is, first of all, you look at the square term. You have x squared, you have y squared, and one positive, one negative. Okay, we know we are going to have a hyperbola. The next thing is you have to find the complete square. You use complete square and change this into the good form that we have as the standard form. So we're going to combine this and this. See, we have 4. We factor 4 out. I get x squared minus 6x. All right, now this one I subtract 9, factor that out. I get a y squared plus 10y minus 153 equals 0. Okay, so you can tell what I'm doing right now. And next step, I'm going to complete a square. because this coefficient of the square term is 1. So how do we complete a square? We just take the linear term, use that coefficient, chop it in half, square it. Okay, so which means chop this in half, I mean -3, and then square it, so I get 9. What I do is plus 9 minus 9. Okay, and this one is 9y squared plus 10y. This coefficient is 1, this coefficient is 10. Cut that in half is 5. Square it is 25. So plus 25 minus 25 right away. Every time when you add something, you minus something. So you're not changing the value, just only change the look. So minus 153 equals 0. All right, now this is a complete square, and that is x minus 3 squared. But this is negative 4 times 9 is 36. And then go ahead. This is 9 times here, complete a square, which is y plus 5 squared. Okay, now negative 9 times negative 25. I got a positive 225 minus 153 equals 0. Okay, we feel pretty good right now. So I get a 4x minus 3 squared minus 9y plus 5 squared. What is this? Negative 36, negative 53, I get a negative 189. And then plus that, I get a positive 36 equals 0. All right, now almost done, but not there yet. I have to bring this to the right and then make that to be a 1. So I get a 4x minus 3 squared minus 9y plus 5 squared equals negative 36. How do I make the right side to be 1? I divide it by negative 36. Now, good thing happened. When you divide it by negative number, this part becomes positive. So I get a 9y plus 5 squared over divided by negative 36. That becomes the positive part. And then plus 4x minus 3 squared over negative 36. And the right side is just divided by negative 36. All right, now negative get canceled. So I have a y plus 5 squared over 4 minus y minus 3 squared over 9 equals 1. Finally, okay, we have done so much work, and finally we get to this is standard form. All right, now this is like the review session, right? How to complete the square. All right, how do you graph this? Center H, K. This is y squared has the positive coefficient, so we should have this up and down. And that looks like this. It's y minus k squared over a squared minus x minus h squared over b squared equals 1. Now, what do we know here? We know hk, y minus k, y plus 5. So here should be negative 5. Okay, and here x minus h, x minus 3, so my h should be 3. Very good, I got my center, 3, negative 5. Very good, right? And what about the a? A squared is 4, so a is 2. B squared is 9. See, in this case, your b squared is greater, right? It doesn't really matter, because I never said that a and a b, which one is greater for this hyperbola. So my b is 3. You find a c squared. C squared is the longest one, right? C squared is a squared plus b squared, which is 13. I don't know if I'm going to use it or not, but just write it. All right, ready? So I have this graph. X, Y, 1, 2, 3, 1, 2, 3, 4, 5. Here's the center. There's a 0, 1, and a 1. Let me just write it that way. All right, now, because this is an up and down part, if I go up and down by 2, so from here, if I go up by 2 and then down by, this is negative 5. So down by 2, here's negative 7. What do I have? I have my vertices. And if I go left and right by B, which is go to the left, which happen to be here, and the other one is a 3. So I get this box, right? So I go up and down by 2, left and right by 3, and then I can go ahead and then grab this. I have this asymptotes, and when I graph, I know it's going to be up and down, so I go. There you go. That's it. And now let me just ask you quickly, can you find the equation of this asymptotes? Yep, because this hk is 3, negative 5, so y minus negative 5 should be plus minus, the slope is what? Is 2 over 3. So it's 2 over 3 because right over right, plus minus, then x minus 3. Therefore, y plus 5 equals plus minus x minus 3, yeah. And then you go ahead, you take a plus, so y plus 5 equals 2/3. You distribute this in, you take the positive, so it's going to be minus 2, right? Because 2/3 times that, and then you subtract a 5. If you subtract a 5, you get y equals 2/3 x minus 7. So that's the first one, all right? And the second one, just take the negative, so y plus 5 equals negative 2/3 x minus 3, which is negative 2/3 x plus 2. And then you subtract 5 both sides. So you get the second equation, which is negative 2/3 x subtract 3. So that's the two equation of your symptoms. I think I covered enough for hyperbola. Again, you now I think you already learned two different conic sections, and the first one is ellipse. You have x squared, y squared, and both coefficients are positive. They're not the same. And for this hyperbola, it's a little bit complicated because we might have up and down and left and right. It depends on which coefficient for the x squared and the y squared is positive. The other one is negative, so we know it's a hyperbola. And we know what is A, what is B. At the same time, you can find a C, and you can, when you graph, you have to draw the magic box. You get the box, and then you connect the diagonal. You get two diagonals, and that's your asymptotes. And then you know the vertices, and you can graph it. So that is the second one we learned, hyperbola.